Hi guys, in the last two lectures we covered the basics of the power system, that is I introduced to you the power systems and I introduced to you the concept of per unit system. In this lecture we will be starting with our first unit, that is transmission and distribution. So this is the biggest unit in the course of power system. In this, whatever are the topics involved are parameters of transmission line, then steady state analysis of transmission line, then transient analysis of transmission line, then voltage control, frequency control, UG cables, insulators, corona, HVDC, and distribution. These are the topics that we will cover under this unit. So this is the biggest unit of the course and one of the most important unit when it comes to the GATE exam. So basically, what is transmission and distribution all about? It is about learning how the power is transmitted from the generator to the load. So usually what happens is power is transmitted from generator to the substation. Substation is the power station near your homes. So that is done by means of transmission line. And then the power is transmitted from the substation to the consumer by means of feeders and distributor. Okay. So there are two ways to transmit the power: by means of overhead lines which are hanged on the towers, and by means of underground cables which are laid under the ground whenever the overhead line construction is not possible. But most of the power transmission takes place by means of overhead lines. Why? Underground cables, first of all, the cost is high and it has severe limitations also, where it can be used and where it cannot be used. Like the heating of the underground cable will be more, as it will not be able to radiate the heat to the atmosphere. So that poses one other limitation on the UG cables. So that is why overhead lines are more common. And most of the transmission systems are three phase, except the distribution systems near our home, they are single phase, as well as the railway traction system is single phase. But mostly power is transmitted in terms of three phase. Okay. So here we will study AC transmission as well as DC transmission. So basically DC transmission is used for bulk power transmission over longer distances. As the power generation is AC, so whenever we are using DC transmission, we are basically converting AC power into DC and then transmitting it. So that conversion process takes place by means of power electronics converters. That is why DC transmission is costlier as compared to the AC transmission. So let us first start with the transmission lines. Basically, in the network terminology, we encounter two terms. One is the node, other is the branch. So here in power system, node becomes a bus and branch becomes a transmission line. So basically, transmission line is used to connect two buses. It will be represented like this. It will be the sending end, which will be sending the power, and it will be the receiving end, to which the load must be connected to absorb the power. And this is our transmission line. So this is bus 1, this is bus 2. So transmission line connects bus 1 and bus 2, and it is used to transmit power between bus 1 and the bus 2. It is usually made of the conducting material, as it has to conduct the current. So it can be made of silver, gold, copper and aluminium. These all are conducting materials. But mostly the material that is used to construct the transmission line is aluminium. Now the question comes, why only aluminium? As in machine we study copper. So obviously copper is a better conductor than aluminium. Then again, why have to go for aluminium? The first and foremost reason is cost. In machines, we have to use the wire only for producing the winding, or for creating the winding. But in case of transmission line, the power has to be transmitted over hundreds of kilometers. So making a transmission line by the use of copper, gold or silver will be very costly. So first is low cost. Then the next thing is aluminium has lesser density as compared to copper. So it will be lighter in weight. And when we talk about overhead lines, they have to be hanged on the tower. And when they have to be hanged on the tower, we have to make sure that the tower is not overstressed. Otherwise, a heavier line has more chances of breaking down when it is hanged on a tower. That's why a lighter transmission line is more useful when it comes to overhead lines. So lighter in weight, that is your aluminium. So it is more used. Now resistivity of aluminium is greater than resistivity of copper. So that means it is a poor conductor as compared to copper. Then how is this an advantage of aluminium? Now suppose if we say resistance of copper and aluminium is same. Now it will be rho aluminium length by A aluminium, rho copper length by A copper. Now from this expression, the first thing that must come to your mind is why I have kept length same on both the sides. Because suppose I am laying down a wire from Delhi to Kanyakumari, then the distance between Delhi and Kanyakumari is fixed no matter whether the wire is made of copper or aluminium. So length is fixed for both the wires. Okay, since rho aluminium is greater than rho copper, A aluminium will be greater than A copper, where A is the cross-sectional area. Since A aluminium is greater than A copper, the radius of aluminium will be greater than radius of copper. Now electric field due to a current carrying conductor is, since R aluminium is greater than R copper, electric field in aluminium will be less than electric field in copper. Now why would I want to reduce the electric field? Now in the case of overhead line, it is surrounded by the air. If the electric field due to the transmission line is very high, then what will happen? Air surrounding the conductor will feel a force and it will get ionized, that is it will divide into positive ions and the electrons. And as soon as it ionizes, it loses its insulating or the dielectric property. It starts behaving as a conductor. And when anything behaves as a conductor, there are I square R losses in that. Okay, or we can say whenever anything behaves as a conductor, there is a loss. Now this ionization of air is called as corona. Okay, ionization of air surrounding the conductor due to high electric field is known as corona, and the losses due to that is called as corona loss. Okay, so if electric field is high, then corona loss is high. So aluminium has lesser electric field as compared to copper. That is why corona loss will be lesser in aluminium as compared to the copper. Okay, and corona loss is always undesirable. Why? Because it decreases the efficiency of line. That means efficiency in case of aluminium will be greater than efficiency in case of copper. Now why I am focusing on efficiency? What do you mean by efficiency and why is it important? The thing is, whenever we are designing a transmission line, the purpose of transmission line is to transmit the power. That means when I am sending power from one end to another by the means of transmission line, what I would want is that maximum power should reach the receiving end. Take an example. Let us say I am sending a money via courier, or I am sending money to some of my relative. What I would want that the maximum amount of money that I have sent should reach there. The cut of the middleman who is taking the money should be as low as possible. So transmission line also acts as a middleman between sending and the receiving end. So that means maximum power should reach the receiving end. That is, it is always desirable that efficiency of the transmission line is high. Okay, so desirable is high efficiency. Other characteristic is the voltage drop. If I am generating 220 volt, let us say if I am sending 220 volt, I would want the load to have a 220 volt voltage. But due to resistance of the line, but due to inductance of the line, there will be some voltage drop in the transmission line. That is, if I am sending 220 volt, almost 210 volt will reach the consumer. We want this gap this voltage drop between sending and the receiving end to be low. So drop should be low. So these are the two characteristics that are always kept in mind while designing a transmission line: high efficiency and low voltage drop between sending and the receiving end. These two conditions must be satisfied by each and every line. Now when it comes to transmission line, what are the ratings that we associate with a transmission line? First is the 3-phase MVA or 3-phase apparent power. Second is the line to line voltage. So these are the two ratings that we associate with the transmission line. Now line current will be S by root 3 VL. Okay, this way we can determine the current rating. Now current in any conductor is equal to current density into area. So current rating is directly proportional to cross section area of the conductor, assuming current density is constant. Most of the times we want to keep current density constant because current density is equal to sigma E. If current density increases, that means electric field will increase, which can lead to corona. So that is why we want the current density to be constant, and hence the current rating should be proportional to the cross-sectional area of the conductor. Okay. And the voltage rating. When it comes to voltage rating depends on the insulation level. How? Now take an example of a overhead line. This is my tower, cross arm. This is my insulator disc. Why insulators are used in case of overhead transmission line? Because overhead transmission line is hanged from a tower. If you do not use insulator, what will happen is the transmission line will be connected to the tower. Tower is also a conducting medium, so it will provide the current a path to the ground. And as we all know, current always tries to take the path of minimum resistance. Instead of flowing through the line, it will flow through the tower into the ground. So the current will not be able to reach the receiving end, and if current does not reach the receiving end, the power also does not reach the receiving end. That is an undesirable condition. We always want the maximum power to reach the receiving end. That is why these insulators are used between the tower and the conductor to prevent any leakage current to the ground. Now this tower will have some resistance, let us say R tower. Okay, and here it will be connected to ground. Insulator will have some resistance, R insulator. Now the voltage of any conductor or any system to ground, okay, voltage to ground will be equal to V phase, and voltage between the two conductors will be V line. So that is V phase. So if we construct a circuit between conductor and ground, there are two resistances that are encountered, R insulator and R tower. So the leakage current that flows is equal to V phase divided by R insulator plus R tower. This is the current that will flow to the ground. Now what happens if you keep on increasing the voltage? This leakage current will go on increasing, but this leakage current is always undesirable. Why is it undesirable? Because it reduces the current that can reach to the receiving end. Okay, so that is why while increasing the voltage rating, we have to take care that we are increasing the resistance also, so that leakage current remains constant. So that is why if we have to increase the resistance, we have to increase the insulator resistance. That is why with increasing voltage, the insulation must increase. That is why with increasing voltage, the cost also increases because the level of insulation increases. Okay, so voltage rating is proportional to the insulation level. But the thing is, what happens suppose if voltage rating is exceeded? Suppose the voltage in the system goes beyond the rated voltage, then what will happen? Then this insulation will not be able to work because it is designed based on the voltage rating. The higher the voltage, higher is the electric field, and due to that the insulator may break down and it may start conducting. Okay, so what happens, there can be two phenomena. Either the insulator breaks down and current will flow through the insulator, or there can be the air around the conductor can get ionized and it can form a arc around the insulator, that is called as arcing fault. Okay, then also it will conduct the current to the ground. So that is an undesirable condition. That means the insulation level should always be kept higher as compared to the level corresponding to the rated voltage, because the transmission line is exposed to atmosphere. There can be over voltages in the transmission line. Whereas when we talk about the machine, insulation level is always proportional to voltage rating, because there is no concept of over voltage. The windings are safely protected inside the shielding of the machine. They cannot be harmed by the external atmospheric condition, whereas they can be harmed by external atmospheric condition in case of transmission line. Okay, because it is open in the atmosphere. So the next question that comes to mind is, okay, it is clear to me that transmission line is exposed to atmosphere, so there can be over voltage. But what kind of over voltage and why over voltage? So let us consider what kind of over voltages exist in case of transmission line. So the first kind of over voltage is called as lightning over voltage. So first of all, what is lightning? Lightning is nothing but the clouds that are present in the atmosphere are electrically charged. What happens if there is a cloud? The lower surface is negatively charged, whereas upper surface is positively charged. And we know whenever two opposite charges are separated by a distance, it acts as a capacitor. Now suppose another cloud comes having a capacitance C2. And whenever they rub against each other, then what will happen? There will be charge transfer. Now, in case of RC circuit, time constant is RC. Okay, that means the time that it takes for the charge transfer to take place. Now, resistance, if it is low, time constant is low. That means the charge transfer will be faster. If charge transfer is faster, then current, that is dq by dt, is high. So a high current flows between the clouds whenever they rub against each other due to charge transfer that appears in the form of lightning. Similarly, when the lightning will strike a transmission line, it will induce some charge on the line. So when lightning strikes a transmission line, charge on the line increases, but voltage is given by Q by C. Since charge increases, the voltage of the line also increases. That is termed as lightning over voltage. Okay, so this over voltage, if it is not taken care of, then what will happen? It can damage the insulation on the line. That is why insulation level must be designed based on considering the effect of lightning over voltage. Okay, and here the current that flows in the transmission line due to this over voltage is called as impulse current. It has the range of kiloamperes. Okay, so this high voltage or charge induces the over current also, which called as a impulse current. So now one property of the lightning is that it always strikes the highest conductor. That is why what we do, to protect the buildings, we install a metal conductor which has a height higher than the building, so that whenever the lightning will strike, it will strike this conductor and the current will be discharged to ground. This building is protected. So that means to protect a transmission line from lightning, we have to have something which is higher than the transmission line and can conduct the current of lightning to the ground. So what we do is, when we have a tower, so we place a wire at the top of the tower is called as shield tower, whereas the transmission lines are below this. Now usually these transmission lines are hanged by means of insulators, whereas there is no insulation between the shield wire and the tower. Why? whenever the lightning will strike it, since it is connected to the tower, it will provide a means to the ground. Okay, so this shield wire, what will this do? It will induce a current that is proportional to the lightning voltage and provide that high current a path to the ground through the tower. That is your shield wire. It is used to protect the transmission line against lightning over voltage. Okay, so this can be prevented by means of shield wire. So whenever you go outside next time, try to observe on the high voltage transmission lines or high voltage tower, you will see a thin wire going at the top of the tower. That is to protect it from lightning. Next type of over voltage is called as switching over voltage. Now what happens to protect the power system? We have two types of devices. One is called as relays, other is called as circuit breaker. Now circuit breaker is nothing but two plates that are kept in contact and current is flowing through this. Now whenever you want to break the circuit or whenever you want to open circuit it, you will separate the plates, and whenever two plates are separated by a distance, a capacitance is formed between them. Due to this capacitance, and the line always has some inductance, transmission line has an inductance, and capacitance comes due to the circuit breaker. A LC oscillator is formed. And in case of LC oscillator, maximum voltage is equal to 2 times source voltage. So that is why here the voltage that will be induced will be twice the rated voltage. That is your switching over voltage. Why is it coming? Due to opening of the circuit breaker. But whenever a fault comes, you always have to open the circuit breaker. You cannot keep it closed. That means this type of over voltage is unavoidable. Whenever you will open the circuit breaker, this voltage will always universally be induced. You cannot do anything about it. So switching over voltages are undesirable. Now the question that comes is, whenever we are deciding the insulation level, which voltage to choose or which is more dangerous? Now as I told you, switching over voltage is twice the voltage rated. That means, but lightning over voltage does not depend on rating. If lightning over voltage is greater than switching over voltage, then you have to consider lightning voltage for insulation. But this is equal to 2 times rated. So we have to set some criteria on the rated voltage. So if V rated is less than 345 kV, then VSOV is less than lightning. So insulation level will be decided on the basis of lightning over voltage. If V rated is greater than 345 kV, then insulation level will be decided on the basis of switching over voltage. Okay, so that is the criteria on which we decide the insulation level. But remember, this criteria is only applicable for transmission lines. For the case of machine, insulation level is decided on the basis of rated voltages. Okay. Next is how we can classify the transmission line based on voltage level. Okay, so the first type of transmission line is called as HV transmission line, that is high voltage transmission line. It refers to a voltage level of 11 kV and 33 kV. Next is EHV transmission line, extra high voltage, that is 66 kV, 132 kV and 220 kV. Next is called as MEHV transmission line, that is modern extra high voltage, that is 400 kV. And the last is UHV transmission line, that is ultra high voltage, it is greater than 765 kV. Okay, so based on the voltage level, we will define the classification of transmission line. Now these are the transmission lines. They will carry the power from the generation to the substation. But the power is carried from the substation to the loads by means of feeders and distributors. So distribution voltage level is defined on two bases or in two categories. One is the distribution level for the primary consumers or the industry, that is called as primary distribution. Okay, So primary distribution is always at a higher voltage because this is the power that is being supplied to the industries. So it is done at 11 kV, 3 phase, 3 wire. Then the secondary distribution, that is the power that comes to our households, is 220 volt for single phase 2 wire, that is 2 wires are used to construct a single phase system, and 415 volt in case of 3 phase 4 wire system. Here one wire will be used for neutral connection. Here there is no neutral connection. So these are the two types of distribution level that have been defined for the distribution systems. Okay. But now how do I decide the voltage rating? Because increasing the voltage rating, how it will be disadvantageous is, it will be disadvantageous because the insulation level of the line will increase. Okay, because insulation depends on the voltage rating also, though it depends on over voltages, but over voltage in the case of switching over voltage depends on rated voltage. So indirectly or directly, insulation level depends on the rated voltage. Then it means I must never go for a higher voltage rating. Okay, because otherwise the cost will increase. So how do we decide the voltage rating? In the later on lectures, we will find that real power is given as mod Vs mod Vr by X sine delta. Okay. So here this formula is similar to what we derived for synchronous generator. It is P max sine delta. Now in the transmission line, when we will derive the inductance, we will find out that inductance and reactance is proportional to length. So if L increases, Pmax will go down because reactance will increase. Pmax is also called as stability limit. So stability limit will also go down. That means system will become lesser stable. That is totally unacceptable. So we have to keep either the same stability limit or a better stability limit. That means as reactance increases, we have to increase the voltage level to keep the same Pmax. That is, for a long distance transmission line, we have to keep a higher voltage so that stability is not compromised. Okay. So voltage level is also decided on the basis of length of the line. For longer lines, the voltage level is higher as compared to shorter lines. Okay. And for DC voltage, if DC voltage is greater than 1200 volt, we call it HVDC. If AC voltage is greater than 1000 volt, we call it HVAC. Now all the names that we saw that every name had a high voltage attached to it. So why high voltage? So how can we discriminate between the transmission lines? Like, what is the advantage of transmitting at a higher voltage? Now power is given by root 3 VL IL cos phi. So if power is constant, then IL is given by P by root 3 VL cos phi. So if VL or the voltage rating increases, then current rating will reduce. So the losses in the line, which is IL square R, will go down. In case of 3 phase, 3 IL square R. If losses go down, the efficiency goes up. That means efficiency at high voltage is high. So that means it is advantageous to use high voltages. But what is the problem? That as you increase the voltage level, you have to increase the insulation, due to which cost of the system will also increase. So it has some advantage as well as disadvantage attached to it, but high voltage transmission is used to minimize the losses, because the first desirable characteristic of a transmission line is minimum losses. That is what I told you. That is the most desirable characteristic. Okay. So let us summarize what we have learnt in this lecture. We first saw the concept of transmission line. Then we saw the material aluminium properties. Okay. Then we saw classification of transmission line. based on voltage level. We saw rating of transmission line. We saw over voltages in case of transmission line. In the next lecture, we'll study further about the transmission lines, how they are constructed and what are their properties. That we'll cover in the next lecture.